Okay, happy Friday. Oh, some of you get to see this on Monday. Sorry. Anyway, favorite unit graphs of the function, the derivative, and its second derivative. And you compare them. Most of the time, we're going to be looking at derivative graphs. And from the derivative, you go backwards to the function, you go forward to the second derivative. This little chart's kind of a fun one. If I have the function graph, when it's increasing, hang on, it's increasing. Critical points and possible extrema, those you can solve and find them, right? Or it's decreasing. It's concave up. Points of inflection are where it changes concavity, and then you have concave down. Well, if the function graph is increasing, your first derivative is positive. Your critical points are equal to 0, your first derivative, or this is negative. Okay? If the function's concave up, your first derivative is increasing. Your points of inflection are the max and min. And if it's concave down, this is decreasing. Okay, the second derivative, you can't tell any of that, but you know that if it's concave up, your second derivative is positive. Your points of inflection are 0. And if it's concave down, your second derivative is negative. You'll notice how the chart just sort of shifts over. These shifted down to here, these shifted down to here. The tangent line doesn't really fit in here very well, okay? I'm not sure why that's on there. So we'll come back if I can ever figure it out, okay? You want to differentiate to determine the derivative. Identify the 0 slopes of the original function, or the highest and lowest. I don't call them peaks and valleys. It's just silly. I don't know what they're talking about. All right. If you have a positive slope, you're above the x-axis. A positive slope on the function, your derivative graph is above the x-axis. If you have a negative slope on the function, you're below the x-axis on the derivative graph. Okay, that's the derivative graph. This is the function. All right. These are asking you to sketch a possible graph of the function itself. Now remember, this is the derivative. You can't read that very well, but this is the derivative. When it equals 0, you have max and mins, right? Well, your derivative is negative here and positive here. You changed from negative to positive, so you have a min. X is equal to a. Okay. Here you change from positive to negative, so you have a max at B and negative to positive at C. All right. These are points of inflection. Here this tells me your first derivative is positive, so it's increasing. Okay. Here it's decreasing. Here it's increasing, and here it was decreasing, which makes sense. So on the function itself, we don't know the y values, but the x is something, right? There's a minimum. My function was decreasing because this is negative. I hit a minimum. It's increasing. We know at 1 it changes from concave down to concave up to concave down, right? 'Cause if this is increasing, it's concave up. If it's decreasing, it's concave down. And we have a max. It's decreasing, so it's still concave down. We have a point of inflection, switches to concave up. At C is a 0. So this is C. This is B. This is A. And it's increasing. Okay, we don't know the y values, but this is a possibility. What's interesting, this is an x cubed. This is an x to the 4th. Makes sense. The derivative of x to the 4th is 3x cubed. It goes down by 1. So if I wanted to graph the second derivative, it'd be an x squared, right? This is an x to the 4th. This is an x cubed. f double prime would be an x squared. Okay? So these are the things you need to be able to read off a graph, more so than graph of them. All right, here we're crossing the x-axis. They're mins and maxes. My min, my max. Mins changes from negative to positive, so that's at negative 3.5, and at 4, there's a max at 0. Okay, I'm increasing from negative 3.5 to 0, and from 4 to, I don't know, we'll just stop here at 6 and make our life easier, okay? Because this is positive. Your derivative is positive. It's above the x-axis. Here it's below the x-axis. Below the x-axis, it means your derivative is negative. All right? So it's decreasing from negative 6 to negative 3.5, and from 0 to 4. Let's talk about concavity. Concave up, when this is increasing, so negative 6 to negative 1.5, 1.7, who knows. It's increasing from 2 to 6. Okay, it's concave down from whenever this is decreasing. So that was negative 1.7 to 2. That's good. Alrighty? Things to read. Nifty. Alright, you can do that one. That's more of the same. This is a good one. They gave you the graph of the derivative. You have to pick which one is, could be f. Well, if you look at this, it crosses at 1. It went from positive to negative. So it has to be a max. So there has to be a max at 1. Well, this isn't a max. That's not a max. That's not at 1. So here's your choice, and you're done already. You want to check, make sure. Here it's negative, so it should be decreasing. Sure enough, it's decreasing. Here it's positive, so it should be increasing. Here they're all positive, it's increasing. Okay. This from here to here, it's a decreasing function. This is concave down. Nice comparisons. Oh, pay attention to that. Watch it again if you have to. Okay, here's the graph. It says, when is the function increasing? Well, it's whenever this is positive. Okay, so that's negative. I can't read that. Negative 2. Okay, increasing negative 2 to 4. And I never include the endpoints. Oops, and then it looks like from 4 to infinity. You don't have to leave that point out. You could have said negative 2 to infinity, and it's acceptable. The EP College accepts that. Okay, it's decreasing negative infinity to 2, negative 2, because it's below the x-axis. Where does it have a local max and a local min? Changes from negative to positive is a min. And it's just asking for the x values. Here it doesn't cross, so it doesn't change from positive to negative, so it's neither. So that's all there is. Okay? You practice that one, you can go check your answer. Okay? Asking for concave up and down. Okay, so up is when this function's increasing, so it increases from negative 1 to 1, and from 3 to 5. It doesn't matter that it changed from negative to positive, it's just the fact that it's increasing. Okay? And it's down where this is decreasing, so negative 3 to negative 1, 1 to 3. Okay? Points of inflection are when these are 0. So negative 1, 1, and 3. Remember, these are the max and mins on the function, because your first derivative is 0. Here, your second derivative is 0. Okay? Here we go again. Concave up, concave down. Up is increasing. Down is this one and this one. Okay? Points of inflection, these points here. I didn't write very specifically. Oh, this one, we got to clean the mess up first. Pew. All right. does it have a local max or min? That's good. They changed back. So here it changed across the thing. Min is negative to positive. Max at 0. Here it doesn't cross. It sort of looks like it's a sharp point, so it's not differentiable. So it could be, but it doesn't cross the line, so it's not a min or max. Concave up and down. 0 to A to C, it's increasing, so that's up. And D to E. And G to H. Down. C, what's that, C to D. E to G. Okay. Possible inflection points would be C, D, and E, but E isn't because it's not differentiable. Okay. Not diff. If that's a sharp point. If it's not a sharp point, okay, that could be a curve. We don't know. It's hard to say. We've blown it up too many times. Okay? Same, you can do that one. I want to do these charts. All right. The first time I did this, I didn't read carefully. So go back and read carefully. This is let f be a function that is even and continuous on the closed interval of -3 to 3. The function f and its derivatives have the properties that are indicated below. If it's even, it reflects across the y-axis. I missed that the first time too. Oh my goodness. So now let's do this right. Okay, so it's telling me at 0, this is at 1. At 1, we're at 0, so it is here also. At 2, it's at -1. And we don't know what happens at 3. Okay? Except that we know it's negative. It's down here someplace. We don't know. And here, it's between 0 and 1, it's positive. And between 1 and 2, it's negative. All right? So this is going to be up here. These are down here. All righty. Now, the first derivative is undefined at 0. So that if it's undefined, it has to be a sharp point, right? It's because it's defined, but the derivative is not. The derivative is negative between 0 and 1, which means it's decreasing, but positive. So it's concave up and decreasing. This is equal to 0 here, and it changes from positive to negative, so it's a point of inflection. It's concave down between 1 and 0. This is undefined, so another sharp point, and this is negative, so it's still concave down. Okay, so it comes here, here, here. Okay. Oh. So the absolute max is at 0. And absolute min is at 2 and -2. The fact that it's even tells you that it reflects across the y-axis. You gotta know that, okay? All right. What are the x-coordinates? All points of inflection. The points are inflection we have is at when it changes from positive to negative, so it's going to be at 1 and -1. And we know that because this changed. Here it stayed negative. Here we didn't know. All right? That's a good graph. That's a tough one to think about. I'll stop scrolling for a minute and let you look at it. All right. Here's another one. Same thing. You got to draw the picture. All right. -3 to 3, and it doesn't tell me anything else. All right. So, on the interval from -3 to -1, your first derivative is positive, so it's increasing, and it's concave up. Okay, at x equals number, it fails to exist. Okay, between 1 and -1 and 1, it's negative, so it's decreasing, and positive, so it's still concave up. So it looks like it goes like this, and this, At 1, it's 0, so it has to be, it's negative and negative, so it didn't do anything. This is positive and negative, so it changes concavity from up to down. Okay? Ugh. And it's decreasing. Absolute minimum and maximum. So the min is at x equals 1. It's just asking for the x coordinates. Okay? Absolute min, we don't know. Because this keeps going down. It's not this. All right? Oh, it's on the interval from 1 to 3. From 1 to 3 was negative. So at x equals 3 is the min. And this is the max. Because this stopped here, right? Has to be concave up. Oh, I guess. We don't know. I guess it could have gone like this. And this is decreasing and concave down, so we don't know. Good question. Points of inflection on the graph. The second derivative has to change and be 0, so it would be at x equals 1. Okay, because f double prime of x equals 0 changed from positive to negative. Ooh, good stuff. All right. It tells us that the f of x, the first derivative and second derivative are all negative. So this has to be below the y-axis, so that throws that out. The derivative is negative, so it's decreasing. And the second derivative is negative, so it's concave down. Good thoughts, y'all. So it has to be concave down. They're all concave down, but it has to always be decreasing. So here you are. Because this is increasing. This one's increasing and decreasing. So the answer is B. Oh, what a good lesson. Y'all go back and do the problems I skipped. All right? Be ready to ask me questions about them. Because this is good stuff.